Hi guys, this is Tiffany Martin and I wanted to do a video on staining and in particular the gram stain. The gram stain is a really big deal in this course. It's the first stain that you'll do for your identification. It divides up bacteria into gram positive and gram negative bacteria. And so I just wanted to go over how it works and maybe this will help you with the labs. So I'm going to use my handy dandy whiteboard here, so I hope you can see this. But first, before we start the gram stain, I want to go over the difference between gram positive cells and gram negative cells. And you should have learned about this in your studying. But a gram positive and a gram negative cell, they both have a cell membrane because all cells have a cell membrane. So that I've drawn in black here. So both gram positive and gram negative have a cell membrane. And then there's some differences. So gram positive cells have a cell wall made up of peptidoglycan, and it's really thick. So I've drawn this in the green there, and you can see that's a very thick cell wall. And that's it for gram-positive cells. They've got teichoic acids, lipoteichoic acid. You learned about that in chapter 3, but it's this thick cell wall made up of peptidoglycan that's going to make a difference in the gram stain here. Gram-negative cells also have a cell wall, also made up of peptidoglycan, but it's much thinner. So I've drawn that in this thin green line over on this side. And gram-negative cells have an outer membrane made up of those lipopolysaccharides that help protect it a little bit more. So there's a difference between cells that are, there's just a difference between cells. And a guy named Christian Graham came up with this staining technique that allows you to differentiate between these two types of cell envelopes. Remember, cell envelope is cell wall, cell membrane, cell wall, and then anything else, outer membrane or whatever else is the cell envelope. So he came up with this certain staining technique that allows us to differentiate whether a cell has a gram-positive cell envelope or a gram-negative cell envelope. Now, all stains will stain the cell. That's a simple stain where you just add a stain like methylene blue, crystal violet, safranin, malachite green. All of those are simple stains and they will bind to the cells and allow you to visualize them. So that's a simple staining procedure. And all of those stains will bind to this cell wall. They bind to that peptidoglycan cell wall. Okay, so let's talk in particular about the gram stain. So I'm going to take just kind of a cross section through each of these cell walls, and we're going to go through the 4 steps of a gram stain. Okay, so step 1, you've got the primary stain, which is crystal violet. Step 2, you're going to add a mordant, which is Graham's iodine. Step 3, you're going to add a decolorizer, which is an alcohol acetone mixture. That kind of rubbed off on my thing. And step 4, you're going to do a secondary stain. So if you do these steps in this order, these cells are going to stain differently, and we're going to be able to differentiate a gram-positive cell from a gram-negative cell. So that is a gram stain. So let's go in order and see what each of these steps do. So primary stain just means it's the first stain we use. It's crystal violet. Again, it's going to bind to the cells. It can be used as a simple stain. It's going to bind to the cells, and where it binds is in this peptidoglycan. So I'm going to take a purple marker, and we're going to take crystal violet, and you're going to put that in your cell when you do your virtual lab or in your real lab. It's going to bind to this layer of peptidoglycan. So now I have my green layer of peptidoglycan and it's covered in purple. It's covered in that crystal violet because that crystal violet has bound to that. You let it stay on for 1 minute and then you rinse it off, so nothing else. But the crystal violet that is bound here won't easily rinse when you rinse it off for that. Okay, the next thing you're going to do, and what color are both of these cells at this time? Gram-positive cells are, yep, you probably said purple. That's true. What about at the end of this first step, what about the color for my gram-negative cells? They are also purple. That's all we've done. All we've done is add crystal violet. So both of these are going to be purple. All right, so the next step, the second step, is going to be adding a mordant. And the mordant is that we use is called Graham's iodine. And a mordant, the word mordant just means it's kind of like mortar, like bricks and mortar. If you've ever built a brick wall or seen a brick wall, we've all seen a brick wall. They've got the bricks, which are very strong, but then to pull them together, they put this layer of like cement in between it. And that makes those bricks stand together, stick together, and make up a wall. Well, the Graham's iodine is going to serve as a mordant. It's going to bind to the crystal violet that is on the peptidoglycan, and it is going to stick it really hard into the peptidoglycan. So here I have my crystal violet bound to both, and I'm going to add my mordant. Now the deal is that my Graham's iodine will bind to this crystal violet, but in a gram-negative cell, it has that outer membrane. That outer membrane is not soluble. The Graham's iodine is not soluble through that outer membrane. That outer membrane that I drew in blue is going to protect it and keep those Graham's iodine from getting in. So gram-positive cell, no outer membrane, iodine comes in, binds to crystal violet, and it serves as a mordant. It solidifies and puts it in there so it won't go away. Here, crystal violet is there, but the Graham's iodine can't get in. Some of it might, but not really much, especially you're only going to put this on for a minute. Just cannot penetrate through that outer membrane and stick. So at the end of step 2, what color are my cells? My gram-positive is purple, so is my gram-negative. Because again, all I have is this crystal violet. The Graham's iodine doesn't have a color to it, so both cells are going to be purple at the end of this step. Okay, step 3. Now I'm going to add decolorizer, which is made up of alcohol and acetane. And this is going to dissolve my outer membrane. So I've got my crystal violet. And in my positive cells, my crystal violet is attached to the iodine, that mordant. So my crystal violet is stuck to the cell wall very tightly with the iodine. This one, I've got crystal violet, but it's not stuck as tight because that Graham's iodine couldn't get there. My alcohol acetone is actually going to poke holes and kind of destroy this outer membrane. So now the peptidoglycan layer is not as protected. You can get to it. Things can get to it. So my alcohol and acetone is going to destroy that outer membrane. And since the crystal violet is not bound very tightly, that crystal violet is going to come off and it's going to come away. Now this one, the crystal violet is bound much tighter, and it's going to take a longer time for this to get away. This is why this decolorizer step is so important, the timing wise. You're only going to drop it for a few seconds. You're not going to leave it for a minute like you did in those other steps. Timing is very important because if you do it too short a time, then you're going to leave some crystal violet here. If you do it too long a time, you're going to actually strip off this. I mean, you know, a brick wall can be destroyed. If you decolorize it for too long, then that alcohol acetone is going to destroy this crystal violet and pull that off too. So the timing is crucial in this step. But what happens is if you do it at the right time, crystal violet here stays, crystal violet here goes away. So what color are my cells at the end of this decolorizer step? At the end, you put the decolorizer on it, and then you rinse it off to stop the reaction. At this stage, my gram positive is purple. What about my gram negative? What do you think? All right, well, my crystal violet is gone. There's nothing else on there. These are going to be clear. Okay, there's no color on it anymore. Remember, that's the reason we use the stain is to visualize it. These are going to be clear. My crystal violet went away. I still have my peptidoglycan thin layer, but I don't have my outer membrane anymore. These cells are going to show up clear if you looked at them at the end of the gram stain. At the end of the third step of the gram stain. Okay, so step 4, we're going to do the secondary stain. We're going to add the safranin. It's going to stain just like crystal violet did. It's a simple stain. It's going to bind to that peptidoglycan layer. And over here, I've got my gram positive cell, but it already has crystal violet bound to it. Remember that iodine is still holding it very tightly. So it's already got crystal violet bound to it. There is going to be a little bit of safranin binding, but not very much because there's not very much room. And even if it does, safranin is a light pink stain and crystal violet is a deep purple. Who are my art students? When you mix crystal violet with a light pink, when you mix a dark purple and a light pink, what color are you going to see? You're just going to see purple. So my gram positive cells are going to stay purple. My gram negative cells, remember we stripped all that crystal violet away, there's lots of room for safranin to bind, and they're going to turn kind of a reddish light pink color. This is a differentiating stain. It's going to, if I follow the gram stain procedure correctly, at the end, gram positive cells are going to look at one color and gram negative cells are going to be the other color. That's right. Okay, so that's the gram stain in a nutshell. A great critical thinking exercise is to go through and kind of make mistakes. See what happens. Go through the steps now that you understand it, and see what happens if I decolorize for too long. I kind of referred to that one. What happens if I decolorize for too short a time? What happens if I mix up and I do saffron first and crystal violet second? What happens if I don't do the Grams iodine step? So go through those with your study groups maybe and talk about what types of things could happen based on the knowledge of the stain, and if you would get the same thing if you would get these results at the end, or if you need to start over because you messed up. So, okay, I hope that helps gram stain. Let me know if you have any questions. Take care.